Hello, and welcome back to Teaching Statistical Thinking. I'm Catherine from Duke University. The last time we met, we explored the relationship between one categorical variable and one numeric variable. In this video, we will analyze the relationship between two numeric variables using a linear regression model. In this example, the two numeric variables that we will use are the number of copies sold in millions and the MSRP or price of the video game. So let's begin. Let's go to Analyze, Fit Y by X, and place copies sold millions into the Y response box and MSRP into the X factor box, and click OK. Now that we have our graph, let's fit a line to it. Click on the red triangle by bivariate fit and select Fit to Line. Note that we are only able to tell correlation between the two variables using our linear regression model, but not causation. If we look at the summary of fit first, we see that an R-squared value of 0.000522 gives us an R, or correlation coefficient, of 0.023, which implies a very weak correlation between MSRP and the number of copies sold. We also have a very leveled slope of 0.029. So, what would happen if we were to take out an outlier? Let's see. I'm going to exclude this outlier, the game Tetris, from our set of observations by simply right-clicking on it and selecting Exclude. Now I'm going to fit the line again. The new line is green. Let's add a density ellipse to our model. Go to the red triangle and under density ellipse, select 0.95. 0.95 simply indicates that 95% of our observations are within the boundary of the ellipse. The ellipse is also a good graphical indicator of correlation. You can already notice that there has been a major improvement just from the removal of Tetris. Our slope has increased to 0.188, and an R-squared value of 0.057 gives us a correlation coefficient of 0.24, which implies a less weak positive correlation between MSRP and the number of copies sold. First, let's interpret our new linear fit equation. Remember that MSRP is X and copies sold is Y. So, for every dollar increase in the MSRP of the video game, the number of copies sold increases by approximately 0.188 million copies. What about the y-intercept? In this context, a y-intercept of about 13.03 million is approximately the number of copies sold when the MSRP of the video game is $0. Though this is not feasible, it is a correct interpretation of the y-intercept in our context. Lastly, let's examine a scatter plot matrix of all our continuous variables. Go to Analyze, Multivariate, and select all of the continuous variables and place them in the Y columns box. Click OK. We can use the matrix to summarize the strength of the linear relationships between each pair of our continuous variables, as well as identify dependencies and outliers. For example, if I examine the relationship between the IGN rating of a video game and the number of game system units sold, I see that there is one outlier, GoldenEye 007, and that the relationship has a correlation of 0.21, which indicates a weak positive association between the two variables. That's it for correlation and linear regression, as well as for the end of this course. I hope you've enjoyed these examples and this dataset as much as I've enjoyed creating and sharing them with you. Goodbye and good luck teaching statistical thinking.